Hello students, welcome to the Yes 201 course. So today we are going to discuss about the recursive functions. So before we start the recursive function elements, let us first of all discuss or clarify what is the recursive function actually. The recursive function is those kind of functions which basically calls to itself. That means what? That means the body of the function must have the call of itself. So it is something like that we if we draw this module as a function, name say x, so I must have the call of this x function within the body of this function, so that basically what it does, it operates in a cyclic fashion. That means the body itself calls the function itself, and then it will start the execution again. Okay, so this is basically a cyclic type of operation is going on while doing the recursive function. Now there are different advantages and the different disadvantages are there in a recursive function. So first of all, you have to discuss or do the coding of a basic recursive function, and after that we will go for the different advantages and disadvantages. So let us proceed. So initially we start the basic example of the recursive function. So here we have to start with definitely with the main, and then we have to go to make a definition of a recursive call. Okay, so first of all, let's start with the include stdio.h. So that we're starting the main function, so just int main. Now suppose I'm taking an example of the factorial program, or you can say that find out the factorial of a particular value by using recursive function. You have already know about the factorial program, which has been done by using the iterative operation, that means by using loops. So we just convert that particular operation or the logic by using that recursive call. Okay, so let us just start the experiment here. So enter data, d, so we have to declare this. So after taking this, we have to make a call. Okay, sorry. Now doing this, we have to just make a call of the recursive function, and we're just writing n equal to fact of t, right? So that the fact will be a recursive function here, and finally just print the value of n. Okay, so this will be the end of the main program. Okay, so right now, after writing this main function, now we have to create our recursive fact function. Okay, so that should be int fact int n. Now we have to check the condition. If n is equal to 0, then we must return 1. If n is equal to 1, then also you have to return 1. Why? Because for both the cases, if the value of n is equal to 0, that means the factorial 0 is 1. If the value of n is equal to 1, then definitely the factorial of 1 is also 1. And in other condition, you have to write what? You have to write this fact just return fact or n into fact of n minus 1 directly. So you can even compute the value, and then afterwards you can return, or directly you can write the return n into fact n minus 1. So it is this particular line is basically signifies that this function is a recursive function, and here we are making the call of this fact from the body of the fact. So that's why it is a recursive. Now when it runs, basically it will call itself again and again and the value of this n will getting decremented one by one, right? So as it is decremented one by one, the value will ultimately reaches to 1, and if it is reaches to 1, then definitely it will return the value of 1, so that the calculation will starts. Okay, so let us just execute that program first. It needs a file name. Just writing the file name as fact.c. Error is 0, warning is 0. Fine. So now we have to so enter data, just putting 5. The value is 120. That is the program is fine. Okay, now what actually happens when you are doing this factorial operation by using the recursive program? Now this recursive program, the nature of the recursive program is that whenever it will happen, or whenever it will make a call, then immediately the temporary value that is corresponding to its formal parameter will actually store into a temporary memory. The temporary memory is actually called a stack memory. Okay, so basically the evaluation happens in this way, that for let's say for initial value, that means for fact of 5, for fact of 5, what happened? It will be actually coming in the body of this program here, and as the body of the program will execute with the value of 5, it will actually never consider or never satisfy these two conditions. So it will immediately return n into fact of n minus 1. So if it is n into n minus 1, then it will be something looks like this: 5 into fact of 4. It will be 5 into fact of 4. In the second iteration, when we perform the second iteration, then immediately what happens? This call will be happen for the fact of 4. That means the function call of this fact with a parameter, formal parameter value of 4. So as it is taken fact of 4, that means again that last statement will be satisfied, and last statement will execute with 4 into fact of 3. That means, and the second call of the fact, I can say it will become something like this: 5 into 4 into fact of 3. Alright, and after that in third call of the fact, it will become 5 into 4 into 3 into fact of 2. And finally, at the last call of the fact, the value will be something like this: 5 into 4 into 3 into 2 into fact of 1. And as we already been said, that when your value become fact of 1, it means it should return the value 1. Alright, so you can easily say that for fact equal to 1, when the value of fact of 1 will be arrived, at the time it will immediately return 1. That means this particular call, fact of 1, will actually get replaced by a value 1. And then what will be the final result? Then definitely it will be something looks like that: 5 into 4 into 3 into 2 into 1. And that one will actually get multiplied to the immediate before value of the calling of the function. So 1 multiplied by 2 will happen. After 1 multiplied by 2, it will be 1 multiplied by 2 multiplied by 3. After that, multiplied by 2 multiplied by 3 multiplied by 4, and finally multiplied by 2 multiplied by 3 multiplied by 4 multiplied by 5. That means the final value will get extracted, and as the final value will get extracted, it will immediately return to the main call of the function. Okay, so that means what? That means actually it is performing a intermediate computation operation and each and every call. Okay, and finally the result will get printed, or result will get returned to the main function. Now, one of the main advantage of this is that this particular kind of operation actually requires minimum amount of CPU consumption. That's why the time complexity or the time taken by this type of program will be very much less. Whereas if we perform the same thing by using a iterative program like loop, then it will be taken much more amount of time. Now, one of the disadvantage of this recursive factorial program is that each and every time when you are writing 5 into 4 into 3 into 2 into 1, it means each and every time it will take some memory, and that memory is actually known as a temporary stack memory, which is to be reserved into the random access memory of the computer. So definitely you can say if the value is very large, then definitely the amount of memory to be taken by your recursive program will also become very much huge. Okay, so that's why in case of space complexity, the recursive program is not so much efficient. Okay, but perhaps we can say that for those programs which having very nominal amount of memory requirement can be implemented by using this kind of recursive function to avoid the more time complexity that is involved for the looping or the iterative programs.